Phil back for some more MCAT podcast, breaking down Blueprint MCAT, formerly Next Step Test Prep, full length 1. How are you today?
I'm doing great. I'm excited. We're going to spend some time here talking about some hydrophobic molecules, some terpenes, which may not sound exciting to most people, but it's kind of a fun thing.
Yeah, it doesn't sound fun to me, so I'm excited for some torture today. All right. So right off the bat, when a student flips the page on the MCAT and they get to this and they start reading passage 6 here and they go terpenes and that there's a trigger warning terpenes, I hate terpenes. What do you recommend students do when they start reading something that they quote unquote know that they hate?
Well, I mean, that could be better than a different scenario when you come across something you're like, I didn't know this existed, which also happens on the MCAT, where you look at the next passage and they're bringing up something that you've never heard of. So you may hate this, but at least you've heard of it, right? Yep. The enemy you know. But I also, looking at this passage overall, and this is something I see in a lot of kind of orgo-focused passages, there's a lot of figure to this and not a lot of paragraph to this.
Okay.
Definitely compared to some other passages. And so I find that students are able to get through passages like this quite a bit quicker because figures just take less time to kind of look at and understand. If they tried to explain every step of this in words, that's going to take a lot more time and be a lot more difficult. So I kind of look at this as an opportunity to maybe try to get ahead of the curve when it comes to timing. Just kind of paying attention to that, and you can maybe get ahead of time a little bit. So this seems like maybe an opportunity to help out with timing, especially if you're feeling a little bit rushed. You might be kind of excited to see a passage like this.
Okay. All right, let's go ahead and jump into that one.
All right, so start off, we have terpenes have been found to be essential building blocks of complex hormones and molecules, pigments, sterols, and even vitamins. Terpenes also play an incredibly important role by providing protection from bacteria and fungus. Terpenes have a basic structure of repeating isoprene or C5N8N or H8N units, and they are grouped according to the number of these repeating units. Monoterpenes contain 2 isoprene units. Examples include menthol and pinene. Vitamin 1A, a diterpene, contains 4 isoprene units. Research has revealed the isoprene rule, which states that adjacent isoprene units and terpenes are linked preferentially between carbon atoms located at opposite ends of the isoprene structural subunit. Head-to-head and tail-to-tail connections are rare exceptions of this rule. So overall, this is kind of talking about just kind of this repeating structure going through here. They mention vitamin 1A, they mention menthol, which is probably something you've heard about at some point. But they're saying that this has a lot of roles, right? There's hormones and pigments and vitamins, and it helps protect you against bacteria and fungi. And so incredibly important thing, and there's a lot of stuff that's kind of connected to this. And so it's something you want to be at least aware of it existing as you kind of jump in here.
Yeah.
They give you vitamin 1A here, which is retinol. So we have this vitamin 1A, we have pinene and cantharidin. Not really sure what's going on with a lot of these molecules. I expect to see a question about some of them, probably especially vitamin A, because there's, that's biologically relevant. Pinene, I don't know if that's biologically relevant or not. That's probably something that's in pine trees.
It's the compound that makes pine scent.
Yeah, it's what's on those those little trees hanging from the taxi cab, or the stuff that gets on your hands and
exactly.
Sticky and stinks. So moving on, we have this in human metabolism, the beta carotene A, a 40-carbon terpene, compound 1, figure 2, is utilized as a precursor for the synthesis of vitamin A1. So this is kind of, taking this general terpene stuff, and now we're kind of crossing the line into metabolism and creating subunits and breaking things down. And so it kind of seems like a logical place for this to go. Mm-hmm. So retinal, note, I remember last week we talked about anything ending in -one being a ketone. Anything ending in Al is going to be an aldehyde, which is going to be a double bond oxygen, but on the end of a carbon chain. So retinal is a key intermediate of vitamin A biosynthesis. The biosynthetic pathway by which retinal is synthesized in vivo from beta carotene has been identified by using specifically O18 labeled oxygen and O18 labeled water. And so basically they're just trying to introduce that we've figured out what this reaction is, and we've graphed it out here. I don't really expect to have to come back to this paragraph hardly at all, because everything that they're talking about here is something that they just showed us in their reaction. But as we look at this, we have all of these steps. E1, I'm guessing that's some enzyme one that they've added in here. Maybe they're going to ask us about what this enzyme is. And then after that, we have all of these compounds, noting that in the second last, we have retinal, which is an aldehyde, just as we expect. And then we're also going to have retinol, which is an alcohol. Makes sense with it ending in OL as well. And then they actually do give us a little information about what these enzymes are. So we have the beta-carotene 15 monooxygenase, and enzyme 2, which is the last step, is the retinol dehydrogenase.
My favorite kinds of enzymes, the dehydrogenases.
Yes, there's a lot of them.
Yeah, we go way back.
Especially if you're looking at like Krebs cycle and citric acid cycle. There's a lot of metabolic diseases built around dehydrogenases.
Yep. Okay.
So,
wow.
We got some questions.
All right. So, question 31. Which of the following reagents could be used to complete the final step of retinol synthesis shown in figure 2? A, AlH4. Was that lithium aluminum hydroxide? What is
lithium aluminum hydride?
Hydride. Okay. B is ozone, O3.
Yep.
C is H2 with, was that palladium, PD?
Yeah, palladium.
Palladium. How did I know that? Anyway.
You've been buying some expensive jewelry, I'm betting. You're all blinged out like Mr. T.
No. And then D is potassium, magnesium, Mn. And then what's O4?
Yeah. So the MnO4 is a polyatomic ion permanganate.
Permanganate. Okay.
Potassium permanganate.
There we go. Yeah. Gotta know these words. So yeah, which of the following reagents? So used to complete the final step of retinol synthesis shown in figure 2. So the question is asking, and this is always the first step, right? What is the question asking?
Yeah. What are you looking for?
Is the question asking what could replace the NADH and that enzyme 2 that they have listed there? Like, what is something else that can do that?
Yeah, basically, what if we wanted to do this in a laboratory setting rather than inside a cell?
Okay. I think it's very easy, again, for a student who's going pretty quickly through this to go, oh, wait, the question potentially could be asking what comes next after that. So you have retinol.
Right.
What's after that? And I'm like, wait a minute, I don't know. Okay, so really the question is potentially what is similar enough to NADH potentially and retinol dehydrogenase? What may that look like? And my guess is that we'd have to look at the structures and go, okay, what's happening here? And really the only thing that I see that's happening is this double bond O at the end of retinol gets changed into the alcohol group at the end of retinol, the vitamin A. And so leaning back on chemistry and all of that fun stuff, the question is, what could force that transition? Is that basically what I'm trying to figure out?
That's basically it, turning that aldehyde into an alcohol.
Okay. I don't know.
So what's actually, is there anything that we're adding or removing to this in terms of like an atom, like chloride? Obviously there's no chlorides added, but
correct.
We do add something onto that.
Are we adding the hydrogen?
The hydrogen.
Yeah.
And so this is a reduction reaction.
Okay.
And if some students are really comfortable with redox stuff, then they'll be like, oh, I need a reducing agent because I'm going from an aldehyde to an alcohol. And like, that's great. That's awesome. But even if you're like really not sure where to go from this, note that we're adding a hydrogen to this. And so it's probably going to be something with a hydrogen. which once again puts us at a 50-50. It's a great place to be. I'm adding a hydrogen to something. Just by looking at the picture, I can eliminate B and D because those don't have any hydrogens. Notice that B and D are actually oxidizing agents, and having a lot of oxygens is a good way to indicate something's an oxidizing agent. And that's actually going to take it in the other direction, going from the alcohol to the aldehyde. So we're looking at for a reducing agent, which leaves us with A or C.
Okay.
Now, beyond that, it's a little bit tricky. It does require a little bit more specific knowledge. Once again, the MCAT, a lot of times, just kind of like looking at something and figuring and puzzling, you can be like, well, I'm down to these two. These two are the only ones that make sense.
Yeah.
But then to make that last push to knowing exactly what the answer is requires a little bit more specific knowledge. And so H2 and palladium is a very powerful reducing agent. And it is going to turn a carbonyl or an aldehyde into an alcohol, but it's also going to add hydrogens to every single double bond and turn them into single bonds. And so that's probably not going to work here because our product has, what is that? 1, 2, 3, 4, 5 double bonds.
Yep.
And so if we used hydrogen and palladium, it's going to get rid of this. We're not going to have retinol at the end of this. We're going to have some other compound.
And is that something that most students should be learning in their chemistry, biochemistry, organic chemistry kind of classes?
Yeah. The H2 and palladium shows up a lot in Orgo as just the way to get rid of double bonds. And so there's a good chance a student saw that in Orgo 1 or Orgo 2.
Okay, awesome. And so that would leave us with A as the answer.
Right, exactly. Lithium aluminum hydride.
Is there potentially a way to get to the lithium aluminum hydride without knowing the H2 with palladium?
Probably not.
Okay.
Because A and C are both reducing agents, and I think because they're both going to turn this aldehyde into an alcohol. Okay. But just the palladium is going to go a little bit farther.
Okay. This is too far. Too extreme.
Yeah, it's why it's like trying to warm up your house and you light it on fire. It's too much. Pull it back a little.
Okay. So definitely, and this is where we talk a lot about what the MCAT is or isn't, and there's a big Twitter stuff going on with the MCAT and Khan Academy and all this other stuff. With some people are saying the MCAT is really just a reasoning test, a logic test, and you don't need any sort of background knowledge. I'm like, well, no, right? It is a critical thinking kind of a reasoning test, and you have to know the background knowledge.
Yeah, and it's a lot of times the reasoning, you have to know a bunch of little things in order to kind of put stuff together. Sometimes you'll see a question that in order to answer it, you need to know about kidneys, you need to know about hormones, you need to know about how proteins work and individual amino acids. And so just kind of building on that, that's also something that I've seen with a lot of students where they they work hard and they learn a lot over the course of a month, and then they take a test and their score goes nowhere. And that really kind of brings you down a little bit. But that doesn't mean you didn't learn anything. Let's say I needed to know 3 things to answer this question. Yep. And I didn't know any to start with. And now I know 2 of those 3 things. I still don't get the question. So you have to sometimes you have to get enough information that you can kind of start putting things together and making those connections. So that's why a lot of times student scores kind of plateau at first and then kind of sharply increase a little bit later on in their prep. So just a heads up to anybody who is prepping right now and feeling I'm spending so much time, my scores aren't doing anything. You are getting better. It's just not necessarily showing up quite yet.
It's funny when you said that the thing that immediately jumped into my head is that image of the dude with the axe digging for the treasure, the diamonds, and he gets to within 6 feet of the diamonds and is like, oh, I give up. I'm gonna turn around, when all he needed to do is just a couple more swings of that axe, he would have gotten there.
Right.
Students don't understand that really the analogy to that is as you're studying, as you're taking practice tests, you're getting closer and closer to that treasure. Don't give up, and don't think you're not gaining ground.
Yeah, and that's something that's a little bit hard for students because in undergrad, a lot of times they're running into stuff that this question is asking about just a single thing. Yeah. And if you know that thing, you get the point. Yeah. The MCAT is a little bit more difficult because sometimes you have to apply data and you have to know 2 or 3 little things in order to actually put it together.
Thanks, MCAT.
Yeah.
All right. Question 32. Let me go and read this one.
So, which of the following biological substances are likely derived from terpenes? We have aldosterone, glucose, insulin, and estrogen. And then a bunch of different combinations of those 4 answer choices. Roman numeral questions.
I love the Roman numeral ones. Says no one ever. So the first thing that popped up to me, and I scrolled back up to the top of the passage here, was I remember that the first sentence here mentioned something about complex hormones. All right, it says terpenes have been found to be essential building blocks of complex hormones and molecules, pigments, sterols, and even vitamins. So then I go here, which of the following biological substances are likely derived from terpenes? I'm like, ooh. So aldosterone, glucose, insulin, estrogen. I'm like, darn it, a lot of those are hormones.
Yeah.
I thought it was going to be an easy one. And then I'm like, oh. So again, my pre-med brain is going, okay, it says essential building blocks of complex hormones. Maybe some of these are not complex hormones that I could figure out. But yeah, is glucose a hormone? I don't think so. Glucose is obviously sugar. So maybe because glucose isn't a hormone, I'll throw that one out. Estrogen obviously is a hormone. So 4, maybe I would keep that. D is the only one that has estrogen in there. Aldosterone is a hormone, I think. Right? Mm-hmm. Obviously, we know aldosterone and its importance and kidney function and all kinds of stuff like that. So that's a hormone as well. So complex hormones, okay. So 1 and 4 are definitely hormones, and the passage told me that terpenes are important for hormones. The one that I'm left with is insulin. So the question is insulin a hormone? That's a weird question. I've never really thought of insulin as a hormone, so I don't know. But because 1 and 4 I know are hormones, I'm going to just pick D and move on.
Yeah, so once again, correct answer.
Yeah.
It is a little bit tricky. Note that they don't say, like, this is useful for, like, energetics or building carbohydrates or anything like that. So crossing out glucose is a great thing. And that's just from, like, outside. Like, I just know that glucose is a sugar, and that's probably not a hormone.
Yeah.
And so from there, you can eliminate A and C, and you're down to B and D, and it's a 50-50. The thing is, aldosterone, insulin, estrogen, all 3 hormones. So it makes it a little bit trickier. But there are different kinds of hormones based on what they're made out of. And so the real key here is just, like, looking at what these molecules look like. They're all giant, like, hydrophobic carbons and hydrogens. They're not really made of anything else. Maybe an oxygen in there. So those are that kind of implies to me that we're going to be dealing with a steroid hormone, which are these large hydrophobic molecules. Basically aldosterone, testosterone, progesterone, cortisone, and cortisol, and then estrogen. And so good idea. If it ends in "one" or is like estrogen, then it's probably a steroid hormone.
Yeah.
All the other ones, I would generally lean towards being a peptide hormone. So that's like insulin, glucagon, ADH, adrenocorticotropic releasing hormone, TSH, luteinizing hormone, follicle stimulating hormone, just like tons of them. There's probably dozens, if not hundreds of them. And so just kind of like looking at this and being like, it's a pretty hydrophobic molecule. It's probably going to be a steroid hormone. Aldosterone and estrogen make a lot of sense for that.
Yeah. Okay. Peptide hormone. That's the word I was thinking of. There we go. All right.
Yeah.
Question 33. The enzyme listed in step 1 of the retinol synthesis listed is most likely classified as A transferase, B lysase, C isomerase, or D oxidoreductase. Is that how you say that? Oxidoreductase. All right. So we go back to step 1 of the retinol synthesis. So this is figure 2. Again, if you're listening and not watching, you should go watch as well. Premed.tv. That's where you go watch. So step 1 of the retinol synthesis. So I'm assuming this is enzyme 1. Here's what it's asking. And it gives us the name of this enzyme 1, beta carotene 1515 monooxygenase. Is that the question? Like, what is that? What kind of enzyme is that?
Yeah, like what classification would that enzyme fit into?
Okay. So taking a look at the molecule before the enzyme takes it, it shows us what it does. It looks like it is adding an oxygen here. Water's coming in and adding this 2 alcohol groups in the middle here. Is that an okay way to say that?
Yep.
Somewhere. Oh man. So you already told us at some point that, I don't know. I was going to say, you talked to us about reduction enzymes for this last step to where the O gets the OH. And it kind of looks like that's what's happening. It's a reduction maybe. So D's the only one that says reductase. I'm like, maybe that's it, right? Isomerase just doesn't sound right. It's like isomerase. That doesn't sound very real. Lysase, like lysing things, like to me sounds like splitting them, cutting them. I don't see potentially anything like that happening. Transferase, like what's transferring here? I don't know, transferring. So I'm gonna go with my oxyreductase and move on.
No, you're absolutely right. So an oxidoreductase, this means it does some form of a redox reaction. It could be oxidation, could be reduction, either way. We already talked about that last step where we added a hydrogen. Another way to think about that is removing a bond to oxygen. So if you remove a bond to oxygen, that's a reduction. If you add a bond to oxygen, that's an oxidation. And so the reverse of that last step would be an oxidation. And so would the very first step of this reaction, because we have like this molecule that has no oxygens on it, and then all of a sudden it's got a bond to oxygen in that first step. And so that's going to be an oxidation reaction, which means this is an oxidoreductase. I like that you looked at lyase and you're like, that sounds like lice. It's going to break stuff. And so that's going to be the, what is that? 1, 2, 3. That's the third reaction that we have going on there. It's a lyase where we cut this molecule basically in half. And now we have 2 retinaldehydes. Not actually aldehydes, just retinal. And then isomerase is just going to move things within the compound, but it's not going to create it's not adding stuff. It's not moving or removing things. It's just moving stuff around within this, kind of like moving a chair in your living room. So if I move like a carbon from one spot to another, that would be an isomerase, just switching it to a different isomer of that reaction. Transferase is just going to add some functional group. It's going to add a carboxylic acid or a phosphate or a sulfate or something weird. Which is not the case here.
Okay. Wow. All right. So it's so nice when you have all the time in the world and you can kind of just talk through every answer choice.
Yeah. I really like that you looked at the enzyme name and you're like monooxygenase, right? So honestly, if you're adding oxygens or anything with oxy, I kind of like a redox reaction from that. That didn't even occur to me to just go look at the name of the enzyme and see if I can make a connection there.
Yeah.
But that was your first gut reaction. I'm like, ooh, that's actually really smart. It's a better way to do that than what I was thinking.
I'm just a smart dude. Making it up as I go.
Yeah, there you go.
Question 34, go ahead.
So a researcher seeks to monitor the conversion of retinal to retinol using IR spectroscopy or infrared spectroscopy. Which of the following will indicate the reaction is complete? So definitely going to require some outside knowledge because there's nothing in the passage about any of these IR peaks.
Yep.
So A is the disappearance of a peak in the 32 to 3500 region, the disappearance of a peak in the 17 to 1750 region, the disappearance of a peak in the 1580 to 1640 region, and the appearance of a peak in the 1700 to 1750 region.
Ooh. All right, so immediately the thing that pops out to me is 3 of them are disappearance and 1 of them is appearance. So the thing that's disappearing is that double bond O at the end. from the retinol. So the question would be, is that double bond O significant in any of these peaks here?
Yeah.
Or does the alcohol group at the end now of retinol, the OH at the end, is that significant for the peak, the appearance of the peak in that 1700 to 1750 range? I used to be a savant when it came to
IR spec. You can just glance at it and then draw
IR,
the whole
yeah,
molecule.
and NMR, all that fun stuff. Like literally, we had a lab in organic chemistry, and the test you had to be there for like a half an hour at least, because they didn't want students just to like go, I'm terrible at these, I give up.
Yeah.
But I was so good at them, like I literally was done in like 2 minutes. and they're like, no, you have to stay. I'm like, no, but I'm done. Like, no,
Yeah.
you have to stay. So yeah, that was boring. I don't know why I was good at those. There was just something about them that clicked. But of course, at this point, I don't remember any of that.
Yeah, I talk about that sometimes. Like all the stuff that I've forgotten from med school, it's a scary amount of information that I've lost. But yeah, so definitely going to require some stuff. I like that you're focusing on either losing the carbonyl, losing that aldehyde, or gaining an alcohol. And so it's got to be one of those two. I think the most obvious peak that people can identify in an IR spec is the alcohol. And that's this giant, big, wide valley, somewhere around like 32 to 3,500, which is what they're going on for A. The thing is, as this reaction is complete, we're not losing an alcohol, we're gaining it. So if A had said gaining that peak, then I'm totally on board. And I like that one.
Okay.
A carbonyl, a C double bond O, you just want to know that that's around 1,700. And so, like, after you know that, then the answer must be B for that case. When it comes to IR spec, I know a lot of students are, at least in their undergrad, were kind of, like forced to like memorize, be able to identify like sulfonyl groups and sulfates and phosphates and all sorts of crazy stuff, cyano groups. The MCAT typically doesn't do that. The MCAT's more interested in what we see biologically. So amines, alcohols, and carbonyls are like at the top of the list. Note that those three molecules, amines, alcohols, and carbonyls, those are all found in proteins. They're all found in DNA. And like fatty acids, they have carbonyls and alcohols, but they don't have amines. So like those three things kind of cover a lot of biological molecules. So you want to know that an alcohol is a big wide peak around 32 to 3,500. A carbonyl is around 1,700. That's a C double bond O. And then an amine, like a CNH, that's going to be somewhere around like 3,500, but it's going to be a really sharp peak instead of this big wide one that we see there. I've been able to answer pretty much any MCAT question I've seen on this topic just knowing those three. So if you can just focus on those and make sure you know them pretty well, then that's going to cover your bases when it comes to IR spec. It's a lot easier than what students are used to in undergrad.